So we're going to use our trig identities to write each expression in terms of a single trig identity or a constant. So what do you think I can do for A? What should I change? Tangent into what? Sine over cosine. Perfect. We like it when everything's in terms of sine and cosine because then maybe things will start to cancel out. What else could I do? Perfect. Cosine is like cosine over 1. And if I have a cosine on the top and a cosine on the bottom, they cancel. So then what am I left with? Just sine theta. So that would be our answer. All right, let's look at B. What can I do here? So since I have a 1 minus cosine squared, I'm probably going to use one of my Pythagorean identities. So 1 minus cosine squared would be this one. So what can I replace 1 minus cosine squared with? Sine squared. So I can take out that 1 minus cosine squared, plug in a sine squared. So now I have sine squared over cosine squared. What does this simplify to? Perfect. Tangent squared. Because we know that sine over cosine is tangent, so since it's sine squared over cosine squared, it would be tangent squared. We're using this identity here. So what can I do for C? Remember, we want to try to get everything in terms of sine and cosine. So I already have a cosine. Perfect. I can change cosecant to be 1 over cosine.
Wait, is this cosecant 1 over sine?
Oh, 1 over sine, yes. 1 over sine. So this would be cosine theta over sine theta, which simplifies to what? Cotangent. Perfect. All right, let's look at D. What can I do first? I can change the secant to 1 over cosine. What else can I do? I can change tangent to sine over cosine. Now what? Can we organize this, make it a little neater? What can I do on the top? Multiply. So this would be sine over cosine over sine over cosine, which would just be 1. Perfect. So we could have done it just by changing the top to be sine over cosine. And what's sine over cosine? Tangent. So then I would have had tangent over tangent, which would have been 1. So there's different ways that you can do these. But if you do it correctly, you'll end up with the same answer. Any questions here? So on the next page, we are simplifying the complex fraction. So we're pretty much doing the same thing. We want to simplify. What can I do to simplify? I can change cosecant to 1 over sine. So I can change cotangent to cosine over sine. So I have 1 over sine over cosine over sine. What do I do when I have a fraction in a fraction? Keep, change, flip. So keep the top, change to multiplication, and flip the bottom. So I'm flipping this to sine over cosine. What can I do next? The signs cancel. If we have a sign on the top and on the bottom, they would cancel. So now I'm left with 1 over cosine, which simplifies to secant. Awesome. All right, let's look at B. What can I do for B?
Change the 1 minus cosine squared to sine squared.
Perfect. 1 minus cosine squared would be sine squared. So I have sine squared over tangent squared. What else can I do? Change the tangent squared to sine squared over cosine squared. I can do that. And then what? Keep, change, flip. So I'm going to keep the top, change to multiplication, and flip the bottom. So now I'm going to make it cosine squared over sine squared. Awesome. We have a sine squared on the top and on the bottom, so they can cancel. And what am I left with? Cosine squared. Be careful, it's the cosine that's squared, not the theta that's squared, because that would change the problem. So just make sure that squared is on the cosine. So let's look at number 1 on the next page. What should I do first? Change cotangent to what? Cosine over sine. So this is like saying cosine over sine times sine over 1. What else can I do? The sines cancel. So what am I left with? Cosine. All right, I'm going to go down to number 3. What should I do first? I can change secant to 1 over cosine. What can I do next? I can multiply them together, so that would be sine over cosine. Awesome. Sine over cosine is tangent. What should I do first for number 5? Change secant to 1 over cosine. What about tangent? I can make that sine over cosine. What happens when I have a fraction and a fraction? Keep, change, flip. So keep the top, change to multiplication, and flip the bottom. So I'd make it cosine over sine. What happens next? Cosines cancel. If I have a cosine on the top and a cosine on the bottom, they cancel. So I have 1 over sine, which is cosecant. Awesome. All right, 7. What should I do first? I can change cosecant to 1 over sine.
I have a question. Can't you change sine to 1 over cosine?
You can. So again, there's many different ways that you can do these questions. I think it's most helpful to change everything into terms of sine and cosine, but you could also change it to cosecant. What can I do next? I can cancel out the signs. I have a sine times 1 over sine, which is sine on the top would cancel out with the sine on the bottom. So what am I left with on top now? 1. So I have 1 over cotangent. And what does 1 over cotangent simplify to? Tangent. So again, we are simplifying. What can I do for A? Can I cancel out the tangents? No. You can only cancel it out if I was multiplying. This is like saying x plus 1 over x. I can't just cancel out the x's. It doesn't work that way. If I had an x, like a 3x over x, then I could cancel out the x's. If I was multiplying the two terms on top, you could cancel. But since I'm adding them, you can't just cancel out the tangents. I could split it up into two different fractions. So I could say tangent of theta over tangent plus cotangent theta over tangent. I could split it up like that. So the denominator would have to go with both of them. Well, let's see where this gets us and see what, if we can simplify from here. What's tangent over tangent? 1. Let's see if I can simplify cotangent over tangent. What can I do? I can change cotangent to 1 over tangent and keep change flip. So I keep the top, change to multiplication, and flip the bottom. The bottom is tangent over 1, so I'd make it 1 over tangent. What's 1 over tangent times 1 over tangent? 1 over tangent squared. What is 1 over tangent squared? Cotangent squared. So this would be 1 plus cotangent squared. Does 1 plus cotangent squared change into anything? What? So this would be cosecant squared. So in this case, we didn't have to end up bringing them back together because it simplified. Let's go to the one below it, C. What should I do first here? I can change the top to tangent squared. So I have tangent squared over secant squared. What should I do next? I have to change them first. So I can make tangent sine squared over cosine squared. And secant squared would be 1 over cosine squared. Now I can keep change flip. So keep the top, change to multiplication, and flip the bottom to cosine squared over 1. What can I do next? The cosine squareds cancel, and what am I left with? Sine squared. Another way I could have simplified this would be split it up just like I did in question A, and example A. So I could split it up into two fractions. I would have secant squared over secant squared minus 1 over secant squared. What's secant squared over secant squared? 1. And what's 1 over secant squared? Cosine squared. And what does 1 minus cosine squared simplify to? Sine squared. So I could do it a totally different way, but I'd still end up with the same answer. So there's multiple different ways that you can do these types of questions. If you do it correctly, you'll end up with the same answer. So there's only one right answer, but different ways to get there. Okay, let's look at C. What should I do for C? I can't factor out a sign because there's not a sign in everything, but I can factor it. So if we change this to be x's, it would be something like x squared minus 2x plus 1. And from here, I could factor. It's the same thing as this, but instead of x's, it has signs. So it's the same thing. Do I have two factors of 1 that add to negative 2? Negative 1 and negative 1. So this would factor into x minus 1 times x minus 1, which because I replaced the x's with the signs, in my answer, I would just have to replace the signs back in. So I have sine minus 1 times sine minus 1. And that would be my answer. So a question like this, the directions would probably say factor. Because we're not really simplifying here, we're just factoring. And in order to factor, you always need it to be the same trig functions. So we did some examples before break where we had different trig functions, so we would just have to substitute using our Pythagorean identities to make them the same trig function. All right, and let's look at number 1 right below it. So we are simplifying. What can I do to simplify? I can change cosecant to be 1 over sine. What can I do next? I can change flip. So keep the top, change to multiplication, and flip it to sine over 1, which would make it sine squared. So I can make secant 1 over cosine. Awesome. We would do the same thing, keep, change, flip. So keep the top, change to multiplication, flip it to cosine over 1, which would make this cosine squared. So now I have sine squared plus cosine squared. When we have trig functions squared, and especially when we're adding, we may have to use a Pythagorean identity. What would this simplify to? 1. Awesome. So our answer would be 1.